All right, welcome to The Explainer, where we break down big ideas. Today, we are diving into a truly groundbreaking paper. And I mean, this thing didn't just give us a new model, it totally reshaped the entire world of computer vision by asking one simple, kind of wild question.
So this title, it's a bit of a mouthful, I know, but it's from a 2020 Google research paper, and it posed this really radical idea. It basically challenged a whole decade of AI research by suggesting, hey, maybe the best way to teach a computer to see is to use the same tools we use to teach it how to read.
Okay, so to really get why this was such a big deal, we got to talk about the undisputed king of computer vision at the time, the Convolutional Neural Network, or CNN. For years, I mean years, if you wanted a computer to see, you used a CNN, period. See, CNNs were on top for so long because they had this powerful head start. They come with built-in knowledge about how images actually work, something researchers call inductive bias. They just automatically assume that pixels that are close together are related, and that a cat is still a cat, whether it's in the top left or the bottom right of the picture. That was its superpower, right?
Okay, so while CNNs were the champions of vision, a totally different kind of model was taking over another field entirely, natural language processing. You know, the whole area of AI dedicated to teaching computers how to read and write.
And these models, called transformers, were unbelievably good at what they did. They could see all the hidden patterns and relationships between words in a sentence. They just got context and nuance in a way nothing before them could, and they quickly became the gold standard for pretty much every language task out there.
So naturally, this got the researchers thinking, and it led to this absolutely fascinating question. What if you could take this powerful language model and just point it at pictures? What if you stopped thinking of an image as a grid of pixels and started thinking of it as a sentence? And the answer to that question, it was the Vision Transformer, or ViT for short. And the beautiful thing about it was its simplicity. The paper even says they made the fewest possible modifications to that original transformer that was built for text.
Okay, so here's the breakdown of how it works. It's actually pretty clever. First, ViT basically carves up an image into a bunch of smaller, fixed-size patches. You can think of these as image words. Then it flattens each patch out and turns it into a token, just like a word in a sentence. It adds a little note about where each patch came from, its position, and then it just feeds the whole sequence into a standard transformer and lets it do its magic.
All right, so the stage is set. How did this new kid on the block, this challenger that knows literally nothing about images, stack up against the reigning champ that has all this built-in knowledge? Well, the initial results, they weren't exactly what you might expect.
I mean, this was a classic showdown, right? On one side, you've got the seasoned champion, a ResNet, with this powerful built-in understanding of what an image is. And on the other side, you have the powerful but totally inexperienced challenger, ViT, which had to learn everything, and I mean everything, about space and structure completely from scratch.
So they put him to the test on a pretty standard mid-sized dataset called ImageNet. And honestly, the results were kind of discouraging for the new guy. The Vision Transformer, without that CNN head start, just couldn't keep up. It really looked like that built-in knowledge was just too much to overcome.
But, and this is a big but, this is where the story gets really interesting. The researchers started to wonder, hey, what if VT's problem isn't a lack of knowledge, but just a lack of experience? What if you could unlock its true power with just one thing, a massive amount of data?
So that's what they did. They pre-trained it on this huge private data set with 300 million images. And the entire picture just flipped? The Vision Transformer didn't just catch up to the best CNNs out there, it blew right past them. It actually learned the rules of vision so well on its own that it beat the model that had the rules built in from the start.
And that right there is the mic drop moment of this paper. It's the central, game-changing takeaway. With enough data, a model's ability to just learn patterns directly from the source is way more powerful than giving it pre-programmed assumptions from the get-go.
But wait, it gets even crazier. The most stunning part wasn't just the performance, it was the efficiency. The best VAT model took just 2,500 TPU core days to pre-train. Now that number might not mean much on its own, so to really get how big a deal that is, you have to see it next to its rival. And when you see it like this, yeah, it's staggering. ViT didn't just get a better score, it did it using almost 4 times less computing power. Think about that. It wasn't just better, it was way cheaper and faster to train at that massive scale.
So you see, this wasn't just about a new #1 spot on some leaderboard. No. This signaled a massive, fundamental shift in how we even think about building artificial intelligence for vision.
VIT's success really just kicked the door open to a whole new era. It proved that one single general-purpose architecture could be a rock star at both understanding language and seeing the world. It showed us that maybe brute force learning on a massive scale isn't just a viable strategy, it might actually be the superior one compared to carefully engineering these specialized models.
And that leaves us with a really provocative question that researchers are still wrestling with today. If just raw data and massive scale can beat out these carefully engineered designs, what other rules in AI are just waiting to be broken? It suggests that maybe the best way to build intelligence isn't to give it all the answers, but to give it a powerful way to learn, and then just hand it the keys to a giant library.